Today on Vinylidon, I'm going to start this off-the-cuff video with an anecdote. I was at my sister's place enjoying Thanksgiving. We were discussing things, and she looks at me, she goes, "You know what would be really cool?" I said, "What?" She goes, "You remember those phones that we had when we were growing up that would see through, and you can look at the electronics and stuff like that?" Well, at this point, the entirety of my attention is now devoted to what's about to come out of her mouth. I says, "Yeah, sure, continue." She goes, "It'd be neat if somebody put a Bluetooth speaker module inside, so you could listen to music, and when you're done, you could hang it up on the wall, with the music stuff." Well, that's a wonderful idea. And it so happens that about a week later, I was walking to the corner store and I saw a broken Bluetooth speaker. So, like the tech coder I am, I decided I was going to take the Bluetooth module speaker amp section, battery, and buttons out. They work. And so, the next logical solution was to buy a clear phone. So, here is what I bought. It's a Conair Neon. I grew up with one of these, and it felt like Christmas when somebody was giving you a phone call. You had no idea who it could be, but when the phone rang, you ran for it, you picked it up, hope it was for you, and not a telemarketer. Best feeling in the world. So, this phone has some neon bulbs inside. Now, there's a neon, and on the other side, there is a little phone neon right there. It's basically a little fluorescent lamp with a phosphor coating on there. There's a couple of things inside painted with fluorescent paint. So, for example, the bell here, and they're weights. So, weights, like this phone needed more weight. Maybe they were trying to emulate the brunt force beating capabilities of the older phones in the 60s. Let's see, neon cord. And on this side we have the buttons. This is what I grew up with. Clicky buttons. I love clicky buttons. Look at that. When was the last time you saw? Oh, that's nice. No. Oh, yeah. Sorry. I was having a moment there. The buttons are lit up by two LEDs. I'll flip it over. You can see the two LEDs. One's right there. One's right there. We're going to utilize that. We have a couple of engineering challenges ahead of us. First one is A, put Bluetooth module in. So for that, my plan is to separate these two boards out. Figure I can do some machining in the plastic here. And then I'm going to slide the Bluetooth module in between them. I got to figure out the wiring of the buttons so I can then integrate the buttons. What I'll do is I'll mark off what the buttons will be. So for example, one would be on. I'll label that as a power co and things like that. Stick with the phone kind of theme here. Then we got the acoustic side of things. So I want to install one speaker here. I want to install another speaker here. So I'll be removing this section here and figuring out how to install a speaker and keeping up with the theme. Trying not to make it look a little DIY. Trying to really keep it looking good. The next challenge will be getting the neons to run. I'll figure out something for that, but remember, it's a minimal design impact. We want to keep it looking the way it is. My other thought is to maybe install some black light, violet LEDs inside. So you can light up the neon painted sections there. So I'll probably end up utilizing the clicky switch here, so on black light and off black light. It's convenient that we have that on both sides. I'll be installing the battery on this section. We have 4 wires in this cable to work with. So 2 of them will be for the power. 2 of them will be the return path from the amp to the other speaker. We have to think about sound design and acoustics. We're going to try and make this sound tolerable as well as a plastic phone case can. So that we got some design challenges ahead of us. All right, let's get into taking apart the phone. Let's start with the handset here. Yeah, this project is going to be off the hook. Yeah, phone joke. Alright, so there are 2 Phillips screws underneath here. Let's go ahead and take them out. Alright, and there are 4 clips, 2 on the bottom and 2 on the top. They need to carefully pop apart. Just like that. take this out. Probably going to end up gluing the plastic post back in, and then giving these weights a new paint job. There you go. Pull that out later. Pull the other weight out now. It's too big. Pull that out. So I'm thinking I'm going to actually rebuild these. So I'm going to not use the jacks. I'm going to be clever. I'm going to keep the jacks in, but I'm going to actually hardwire and run the phone line through. Let me explain to you why. There's one big reason. Look at a cord like this. Now I'm going to keep the original cord, but it's a really long cord, has a really thin conductor on the inside. This means it's basically a low value resistor. So it measures about 2.5 ohms going through the cord. And we're dealing with power, or the speakers. Now we're going to be running it both ways. Well, one way for the positive and one way for the negative, which is going to be like a 4 ohm resistance inside this wire, which is no good. If you're driving two 4 ohm speakers, which we will be, this right here is going to end up taking like half the power away, if not more, and just turning it into heat. So what I'm going to end up doing on this is I'll cut the cable, and then I am going to use the heat gun to wrap this around, not wrap it around, make it straight, kind of clean this up. I'm going to run the cable directly through the connector and hardwire it. So that way I don't have these ends. Now anywhere where you have a connector like this and a connection, of course also going to lose connectivity as well. So I want to omit these, but I will still use the plastic jacket. Probably end up drilling out the front, gluing that into the plastic piece, and this will just act like a strain relief in that case. So that's my plan for the cable. Moving on. Take out the boards. No, we won't be needing that speaker, so we're going to take that speaker right off too. Just like that. Oh, there's another screw hidden right there. I see it. Flip that over. There's those two LEDs. Clicky switch. And then we got this panel right here, which is the switch panel. So we're going to have to figure out how that's wired up, how we're going to interface it with the Bluetooth board. It's going to be interesting. For now, let's take that out. Alright, so there's our main board, the headset, and our button board. What are we dealing with? Well, it looks like we just have gold-plated, fancy gold-plated contactors. Carbon looks fairly good on there, so hopefully that'll make a nice connection. It's going to be important that these make a really good solid connection, and I'll of course explain that later on in the video, but that looks promising. Looks promising indeed. So here's the mainboard. This is what has the 2 neons on it. Oh, there's it. There's that one. We're going to end up isolating those neons actually electrically. Now, it looks like that work has already been done for me. Sure has. Alright, well, we're still going to have to make sure they're electrically isolated, because we're going to actually end up lighting up the neons from our audio source. So that will need to be done. I like the fact that there's wiring there already. So let's take our Bluetooth board, see what we need. Oh yeah, that's going to be a bit of a squeeze. We're going to need to maintain this for charging, the USB micro. We're going to take off this headphone jack. probably going to end up taking that capacitor off. And what I'll end up doing is I'll just move the capacitor onto the main board and just run like wires or something. Let's see. Remove these headers. Run the speaker wire directly. Anything we can do to make this board thinner, I'll be doing. Yeah, the other thing I'm going to have to figure out is how to install the LEDs, because of course then we can't have the LEDs passing through this board without it functioning. Of course we could put 2 holes in here, but I doubt that would be any good for it electrically. Well, that's what we have to work with here. I'm going to remove that speaker too. So this is a headset speaker, and I'll see how that links up in size with what I want to put in there. So here's the kind of speaker I'm going to put in. Sounds reasonable. We'll take a look at that a little bit later on, but I figure it's about the same size as the original speaker. And I'm going to paint this a neon green as well to keep up with the theme. So we're going to have to do some, looks like some basic machining. Getting rid of those plastic risers, or at least adapting it so this can sit in here. Let's see. Can I push that in? Oh, it looks about perfect the way it is actually. Hold on. We may have just lucked out. Yeah. I think we can. Oh, those are loose. Gotta make note of that. There we go. Yeah. I'll cut out this section, make some holes and whatnot. Yeah, I like the fit. Looks good. Alright, what do we have on this side? Take off these rubber feet. That'll give us access to the 4 screws on the... Oh, no. That didn't go as planned. Yeah, remove the 4 feet on the base here. Are you kidding me? That didn't help me at all. Yeah. Root force. Good enough. Alright, so here's the base of the phone, and just has some minor parts in it. Looks like a voltage rectifier that sends power to something else. Probably takes and stores a little bit of the voltage coming off from the wall to operate things like the LEDs and the neons. Hanger up switch here. Yeah, not too much. The only thing I'm really gonna pay attention to is the little bulb here and the clicky switch. Of course, I'm going to electrically isolate that too for when I put the violet LEDs on the inside. We got the bell here, got this weight here. I'll probably end up pulling that out just to repaint it. And I got to pull it out anyway just so I can clean it. Oh, remove everything here. Now I think we can take out everything. Oh, let's see. Oh, what's that? A spring. Where did that come from? Where did that come from? Oh, I get it. Okay. I ding. Took me a little minute. Okay, so the spring ran like this, up like that. Yep. Alright, so there's a little tab that was on here, and I think how it worked is you could change the function of the phone. What do I mean by change the function of the phone? No, you could have it as a tabletop phone like this, and in which case you'd have a little tab that would go this way. So that way, if you picked up the phone, the tab would be non-intrusive, and you could pick it up directly straight up and lift it off, and it wouldn't be any kind of intrusion. However, you could also probably take that tab, pull it out, rotate it 180 degrees so the tab would stick out like that, and then it would clip on this little divot or indentation right here, and it would latch on. So that way you could hang it up like this, slide it down, and it would hold that tab. You can hang it on your wall like that. So I think that's what that did. Anyway, I'm going to take this all apart. I'm going to clean up the plastic, and then we're going to take a look at where to put our speakers. I think the other speaker is going to go in the top section right here, so I'm going to fully remove this, and I'm going to mount the speaker and see how well it fits. Probably have to do some kind of custom speaker grading for that. I don't know whether I'm going to do it in a neon painted metal, which I think would look better, or whether I'm going to keep with the original plastic. Either one would look okay, but I think the neon painted grill would be the best way to go about it. What is the diameter? Oh, look at that. It really does. That doesn't say it belongs there. I'd say it belongs there. Okay, well, now that I made a mess on the desk, I am gonna get this all organized. Clean the phone case. We're gonna come back. Got some grimy bits here. Some latex house paint has been spilled on the inside here. You can see where it dribbled on the handset right here. So carefully take that off. Of course, trying not to ruin the acrylic case in the process. Alright, let's talk about the electronics a little bit, and one of the more difficult things to figure out is how to integrate two different forms of button layout into one functional human interface. Now, what do I mean by two different forms of buttons? So, here we have one that is multiplexed, and what that means is that depending on how the wires lead up together, they form a grid. So, for example, you have all these buttons right here. This is connected, this is connected, this is connected. And then, if you take a look at this one right here, here's the other side of the contact for that switch. But it also leads up to, say, this one right here. So depending on where on the grid you press, it connects two wires, and those are received here, kind of like how a keyboard works. However, that is not the case with these 6 buttons here. So how are we going to integrate these? Well, I'm going to open this one up, and I'm going to show you how these buttons work, so you get the understanding of how these are going to need to be connected. Yep. That was already out. Okay. So, let's take a look at these switches real quick. Focus. Alright, so we take a look at these switches. They're actually all in parallel. Well, okay. Well, if they're all in parallel, then how come the device knows when you're pressing this one versus pressing this one? Well, that's accomplished by having a resistor that is in series with each switch. So, for example, there's the resistor, there's the resistor. We go over here, here's another resistor, and so on and so on. Now, how this works is the resistor values are different. So, for example, if you press this one, they'd be like a 5K. If you press this one, 10K, 15K, so on up the line. So what's actually going on is this is detecting the resistance picked up by each button press. This is why I said it's important to see how conductive the rubber membranes are for this. So, for example, say if we're looking for 100 ohms, and this is 60 ohms. Let's say it'd be confused to be like, okay, well, are you pressing the 100 or are you pressing the 50 ohms? But if we're dealing with kilo ohms, the resistance of the rubber membrane isn't going to matter, because the tolerance is going to be negligible. So now what I need to do, I need to figure out which switches I'm going to use on this. In fact, I think it's upside down. So yeah, so I need to figure out which switches I want to use on here. I need to make them all go in parallel with one another and cleverly install the proper resistor values in there. So there's going to be a bunch of rewiring I need to do on here. So first is I need to trace out the connections, then bridge them, and then I'll probably end up scraping away a little bit of the connections here and using the original surface mount resistors provided on this button board right here. So it's going to be a little bit of a trick. Let's see how that goes. Well, that turned out to be a little bit more complicated than I suspected. So it does work the way I thought it did with the switches and the resistors. However, it's a little bit more complicated than just that. So the power switch over here had some transistor here that also work in tandem with this transistor right here on the board. It's some kind of latching circuit. I'm not sure exactly how it works, but I do know that that transistor is important for establishing one of the rails that goes to all the resistors and the switches. So I had to put that in there. That gives us 3 wires in total that I needed for the switches. So I installed the little transistor there that I need for the power on, and I ran all this little EM wire to the common where the resistors go, and I covered the resistors too with some super glue, let it dry, and then I also did all my common negative connections on the switches too by modifying the board, cutting some traces and stuff, which goes out to this wire right here. And then I have my switch. So there's my my positive signal in from that one transistor, and then here's my switch trigger wire that I'll need to hook up, and that goes to the microprocessor and tells that what button is pressed. So hopefully this all works. I haven't tested it out yet. I haven't even connected it up to the board. I figured what I'll do is I'll do that all real quick, and we'll see how it goes. Now my one concern is that I noticed that the wire that connects to the switches with the resistors, that common, is shielded between 2 grounds. So I hope it's not prone to interference, because this might make some interference when the neons and stuff are going. So high voltage is tricky like that. Alright, so I'm going to remove this. We don't need that. And I'm going to make those 3 connections. The first one is going to be ground, and I'm just going to tag that on the outside of the shield. And cut that shorter. And the wire like this, I'm not even going to bother stripping it. A little bit's going to hopefully peel back when I get some solder on there. It's not the way you're supposed to do it. Bad soldering. How dare you. Alright. A little bit of solder on the shield. Just like that. That's going to be the ground. Just like that. And then I am going to need to connect this. And this comes from the wire that connects to all the resistors going to the switches. That will end up being connected to the microprocessor. Zoom in on that so you can see what I'm doing. Not very exciting, but alrighty. Let's see if I can see what I'm doing. So that's gonna connect to that right there. And it's only just a test run, so okay, just like that. Then the last wire gets connected to that tab on that transistor. Alright. Alright, those should be our 3 mandatory wires for turning on the device. Now I also do want to connect up the LED output wires. So on the button board, you'll see that there are LEDs, 2 LEDs by each button. And there's a wire that goes up for the positive connection to all those LEDs, and that shares the ground too. So that connection will be, I need to find my scrapey blade. Alright, that connection will be this one right here. That looks sketchy. Alright, well, gonna have to put that wire back on, but, you know, no problem. Positive LED wire. Switch wire. LED negative. There's all one thing a common ground, so go ahead and do that. Alright, and that'll get us power to these 2 LEDs, which will simulate the load of the 2 LEDs that are already there to light up the buttons. And just to let you know, if you have a single lithium-ion battery, 2 of the old school LEDs, if they're the same kind, will work great in series like this, just off the 3.7 volt lithium-ion cell, which is what we're supplying this with right now. And we'll just see if it makes some noise. So zoom out, or if it makes some smoke. So the speaker. Battery. This is the one you don't want to plug in incorrectly. No smoke yet. That's good. Okay. Slide the membrane on. See if it works. I'm going to try power real quick. See if it does anything.
The Bluetooth device is ready to pair.
Oh.
The Bluetooth connected successfully.
Well, that's good. Do the other buttons work? Not promising. Oh.
Power off.
Well, the good news is it does work. If I went mute there, that's because it's turned on and there's no microphone on. But yes, this does seem to work to turn on and off power. However, I didn't really seem to be getting any functionality with the other buttons. However, it just might be a pressure issue or whatnot. I have to take a look at that over, but I like what I have so far. So I want to see what I can figure out, but it looks like the wiring is solid. Alright, well, I have some good news. So check this out. There was absolutely nothing wrong with it. Everything works perfectly. So what? Turn it on.
SD card playback.
Sound familiar? So let's go ahead and try and change modes.
The Bluetooth device is ready to pair.
Bluetooth works. Excellent. Let's go ahead and do this mode
FM
selection.
mode.
Radio.
SD card
SD
playback.
card. Forward and backwards buttons. Perfect. You do have volume up. Volume down. Yes. Absolute perfection. Well, we're just gonna let that play music in the background while I just put in the other screws in, I guess. Because I have deaf ear. And I'm feeling good about what's going on. If the music stops, I've screwed up. Is that a screw hole? I don't think it is. That's a screw hole. Oh no, that was the right one. I think they're both screw holes. Make sure all the switches work again.
Power off. SD card playback. The Bluetooth device is ready to pair. FM SD card playback.
I love it. I absolutely love it. Okay, I'm going to need to take some time and kind of manage where this is going to go, and I'm going to knock off some parts off of this. So I'm going to take off the large USB port. I'm going to take off the audio input jack right there, and I'm going to probably navigate this capacitor into a different area, and that should look good. Now I also need to make sure that this circuitry right here doesn't obstruct the Bluetooth antenna and cause interference and stuff like that, but so far it's so good. I think I'm going to angle the board this way actually, so that way there's access to the SD card here, which will probably mean I'm going to have to flip the board over the other way, so facing that way. I'm going to go over the back side of this board, and I am going to knock off all of the solder traces, or the pins that stick out from the solder connections and stuff like that, and then take these LEDs out. I should be getting power to these LEDs here. Am I? Very bright shop light. Yes, I am. Alright, so hopefully that'll be enough power for these two LEDs. Otherwise, I'm just going to put these in parallel and run a resistor in series to get the correct brightness I want. But so far, it's working perfectly. Music to my ears! Starting in on day 2 of the project, and I'll show you what I've gotten done so far. So I did get the Bluetooth module installed underneath the board. There it is. lays in nice and flat. Got this little piece of plastic to protect it from any kind of metal that would maybe short up against this. This is my sister's house. I don't want the battery catching fire, burning her house down. I also took the precaution of actually coating this with a layer of epoxy too, just to make sure there's a redundant layer of protection, because it's quite thin. But yeah, all fits in rather nicely. I did end up putting the two LEDs in parallel and running a 100 ohm resistor to the LED output of the Bluetooth board, and those LEDs come on perfect. So looks just the way I want it to. I'll show you later on in the video how that looks, but for now we're going to move forward. So, figuring out how to install a speaker on this side, a little bit of a trick. So, let me show you what I did. I took the button mechanism that was in here, removed it completely, and I ended up making two little cutouts. They could be cleaner, but that's what those are. I ended up cutting out this little bit of a speaker grill, and that slides in just like this. And then I needed to install the speaker. Now, I noticed that the diaphragm of the speaker, the surround, would actually touch the grill, so a little spacer needed to be made. So I did that, and that'll go on the speaker like that, and that'll prevent the surround from hitting the grate, causing poor sound. So it's going to go in just like this after the front is cut out in this circle. And I made this piece, a little bit of a clever piece to make. It took a little bit of thinking. But how this works is it goes into the cutouts just like that, clips around the speaker, and then I'll be able to put two screws in just like that to lock it in place. Now, just like that. And that looks pretty good. So that's my plan for that. Also done some modification on the bottom portion. So pull all this out again, show you what I did. So I ended up using a Dremel, and I cut down some of this section right here. That's where the speaker magnet is gonna come in and rest. And I also shaved out this section here. Sadly, I wish I did better on the two sides here, but I needed to make this ever so slightly wider to get the battery in. For example, I'll drop the battery in here, and you can see where I had to cut it out. Wish I cut it out just on the bottom. Also, it crazed a little bit when I put some acetone on there to try to get some of those little cracks a little smoother, and I didn't like that at all. So it is as it is. But that's okay. I got this board right here. I actually trimmed it down a little bit, maybe about 2 millimeters, 3 millimeters, and I also gave it this bevel. You can see here, like a 35-degree bevel. And what that does is, when it's in place, holds the battery down if it's in all nice and snugly. So get that in, get that pushed down. There we go. So it'll hold the battery just like that. Well, it holds the other battery in a little bit better, but it'll set like that. And then this whole section will actually come together. I'll put one screw in, and I'll show you how that comes together. These, we're gonna put that screw. There we go. Come on, lay flat. There we go. Alright, so with that held in like that, this will slide over, tuck that in for the time being. Boom. Just like that. Now tell me that is not satisfying. That's good engineering. I went to the store, I picked up some spray paint. No, that's why the original battery is not connected right now. Did a test on the battery, figured I can't really ruin that. So I didn't pick up any primer, sadly, so it's not coming out as bright as it could be, but hopefully a few more coats will fix that. Probably not much. And I'm probably going to run into the same issue when painting the speakers and this grill, but we'll see how it turns out. Hopefully it'll look good, but some things to do yet. So I'm going to get to painting and setting up the aesthetic. I think I want to keep one side of it more orange and one side of it green, because if you look, that matches the board. So, for example, that's why I have only one side of the battery painted green. I'll leave the center blue, paint that side orange, just to fit with the ribbon kind of motif in there. And I'm also going to do the same thing with the speaker grill here. I'm going to leave the center area kind of black, and I'm going to do the green on one side. I'm going to do the orange on the other, in that same kind of style. So it should look really good when it comes together. But anyway, I'm going to go masking tape off some speakers and get to painting. And now time for some flying camera action. So I think what I'm going to do is I'm going to paint the centers with the orange, and I'm going to paint the body of the speakers with green, because that's kind of how it looked on the phone. So go ahead and do this. Shake, 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 shake. See how it looks. That's a nice bright orange. Ain't gonna be that bright on the black though. Let's see how it looks. Looks good. Gonna take a couple of coats to really get it to show up, but I think in there. Let that dry a little bit. I'm gonna flip these over. See how that goes. Shake it, shake it, shake it, shake it, shake it, shake it. Welcome to day 3 of the project. I finished all the painting yesterday, and that's all dry. I covered the 2 speakers and the grill and the battery. Looks fantastic under black light as well, but we can take a look at how that turned out. Flip this over. So that's one of the speakers right here. Painted the center orange. I still need to do the holes on the outside to get more sound out of there and make it sound better in general. Looks good. I also modified the bracket up here for the headset speaker, so that way it holds this in. I don't like how it fits in, so I might change that, but it's not that bad. Moving over to the base of the phone, I did the speaker grill, keeping up with the theme. So orange here, green here, same as on the board. I also did that with the battery underneath. So all with the theme of things. It looks pretty good. Flip that over. I want to put some spacers in here, so that way the acrylic can rest in there and the screws can properly compress, and get some longer screws put in there too. But it really does just press up right against the battery, so the battery is also supported with that bracket, and the board as well locks in there pretty nicely. Now a couple of things I need to do. I need to do the wiring. So I've got the battery in here. I need to do the wiring for the power going out. I cleaned up the cable, which turned out pretty nice, and I also shortened it, and I ran the wires right through the connectors. Now this is terrible wire. It still measures about 1.4, 1.3 ohms, so that means it's going to be about 2.5 to 3 ohms going through both ways. It's still not the greatest, but there's some things we can do to make up for that to some degree. And I'm going to be running the power from the battery on the 2 outside connectors, because the most use this cable is going to see is probably going to be during charging. And so say if you're passing like half an amp through a 3 ohm resistor, that's going to get a little warm, but I'm going to keep these separated just physically. That way they don't make more heat next to one another and risk shorting out. The 2 center wires are going to be the speakers. And we can take a look at the cable. I haven't seen this kind of wire in years. Zoom in. So this wire is actually like a copper foil that's wrapped around a thread. So Terrible wire. But it lasted, say 30 years, maybe 40. It still looks this good. And it really is made to be flexed and flexed and flexed. Remember, this phone could have been used daily, multiple times. So it's a workhorse. And it's not that I don't completely distrust this cable, but it's still not the best, and we have to respect our limitations because lithium ion fire. I need to also install something to run the neons and fluorescent lights. So what I'm going to do is I'm going to use a little high voltage transformer, and I'll show you that a little bit more later. But let's see, where's that transformer that I had? I moved it because of course I did. All right, here it is. So I did a test run earlier, and what I'll end up doing is I use, say, a 1 to 2 microfarad capacitor, and I will capacitively couple the output of the amplifier to the transformer, so that way I'm utilizing the high frequency tones just like you would in a crossover. And I'm doing that because if you have the transformer directly connected, this is a sub-ohm coil, and that means that it's going to want to demand more current than the speaker here. And let me tell you, that makes the sound terrible. So capacitively coupling it like this will give us better sound. It will drive the transformer more efficiently, and it won't suck up a lot of power, and we'll still get the sound activation blinky lights of the neons. So that's what I'll do. I'll find a smaller 1 farad capacitor because I don't need one that's rated for 250 volts. I'm only using maybe like 5 volts or so. So I'm going to drop that down to a smaller size, probably use a little ceramic or poly cap. Maybe there's something already on the board that I can use. But I figure I can go ahead and I can just tuck the transformer down in this area, and that'll run the neons on that side. And I have another little transformer that eventually I will be placing inside of the ringer bell. So I'll take the ringer bell apart. I'll take the coil that's already in the ringer bell out. I'll leave the metal mounting yoke in the bell, and I'll put the transformer on the inside of here, and then it'll be nice and hidden. That way you don't see a transformer in the base. It's just a little tiny guy. But that will drive this little fluorescent light right here in the same exact way as the neons are being driven in the handset. After that, I'll do finishing touches like installing the 405 nanometer LEDs. But the first step right now is I need to do the wiring between the base and the handset, so that way I can now start to connect the audio up, start to do the electrical. I can't do any of that really without power and the ability to test that. So that's my goal. That's what I'll be doing, and we'll come back once that's done and address the electronics. And now on to day 4. Wait, what do you mean day 4? This is supposed to be a 2-day project. What were you doing all day 3? What do you mean that the cable is so poor that the voltage drop going to the Bluetooth module from the battery is so low when the volume is high that the whole thing shuts off? What do you mean you had to install a second battery to make sure that it didn't do that? A whole proper charge cycle to make sure that it didn't burst into flames? Duh, that's preposterous. I know, that's exactly what I said. Anyway, so here's what I've done. So indeed, yes, the resistance in the cable would cause a voltage drop about 1/2 volt. So on a fully charged battery, about 4 volts. The power going to the Bluetooth module was only about 3.5, and at high volume it would cut off. Now, I did try installing 2 2200 microfarad 6.3 volt capacitors. It simply wasn't enough. So I took and I used this little lithium ion polymer cell from one of the disposable e-hookah things, and I put it in there and it works fine. I also installed a battery management circuit board on there so it didn't burst into flames, and I think electrically it's okay, although I should probably pair this thing with a fire extinguisher, but for now it looks fine. I pre-wired all the LEDs that I want to install that are ultraviolet. There's going to be 4 of them. I put them on a networking cat wire, so it's solid core, and I can position them where I want them to go. And I also prepared this transformer. So what did I do on this? Well, I installed a little itty bitty ceramic capacitor right there. That's a 2 microfarad. And I have these leads, so that way I can use these as a mechanical connection to hold it on the board and position that where I need it to go. So I'm going to go ahead and real quickly install this and see if it works to light up the neons in the phone, and we'll go from there. But that's my main goal right now. The biggest hurdle is going to be getting those neons to light. I have some silicone wire here that I'm going to use for the neons themselves. It's nice high voltage insulated wire pulled from a CCFL bulb backlight screen. So more recycled wire being put to good use. I'll go ahead and move that over so I can get in there and start installing things. Carefully fold this back. Well, I've also taken time to cut out and isolate sections of the board here, so that way I can hook up the transformer. And I also isolated this switch up here for the violet LEDs, so that way when I go to install them, it's isolated and power isn't being fed back into the rest of the board. So first things first, neons. Well, there are these two rather large sections right here, so this right here, this right here. I think I'm going to fold these leads over, and they should make a good mechanical connection like that, and then it's going to be folded over like this on the board. Let's go ahead and do that. Yeah, I want to have it bent and lined up, I want it closer to the middle, so go ahead and do that. That should work. Okay, now that that's mechanically installed, you can electrically hook it up now. So, I can capacitively couple the neons too, but I don't think I'm going to do that. I think I'm going to see how it works without capacitively coupling the output of the transformer. So, this side goes to there. Like that. And then connect the neons up. Right. So that's going to be one of our audio inputs. We'll run that over to the other connection. Over here. Okay. High voltage wire. That'll connect to the other side of that neon. Not put that back, just like that. And that'll go up to the high voltage output side of the transformer. Alright, and now I need to connect some wires to go from the speaker to the transformer. Go ahead and do that. Alright, so at this point we have our high voltage loop for the neons. So this goes through the primary side of the transformer, through that little capacitor I installed there. And then you got the high voltage side, so it comes out of the high voltage here, goes through that neon, comes out through here, goes to that neon. Here's a return wire right there to that side of the transformer. This is on the secondary. Got these, which are going to end up connecting to the speaker, and then we can see if the neons light up. I hope they do. We're going to find out real quick, aren't we? Alright, that's connected. Let's see if the neons work.
SD card playback.
Turn that off. Well, let's see. Oh, hey, cool. That's promising. Oh, yeah. Tell me that isn't cool. So yeah, I gotta set up the transformer and the ringer bell for the other side, but looking very nice. Very nice. Very nice. As you can probably tell, there's been even more progress on the phone. So I did go hop and finish the handset off camera. It's a meticulous task of installing the little LED wires and then closing up the clamshell, making sure that none of the wires are pinched. So a little bit of a slow, meticulous kind of task, but it is all together. The LEDs I have in parallel with a 100 ohm resistor in series, and they're not very bright, but just enough to give a little bit of an accent. Go ahead and turn off the light, turn that on. So, pretty good. I like it. And of course, you know, we have the neons to keep them company, as well as the LEDs and lighting up the buttons. Oh yeah, that all works. I hope it works. Yep, there it goes. Looks good, looks good, looks good. Turn that off.
Power off.
So now I need to finish the base of the phone. So, this is what I have to work with. So I need to modify the bell, and I need to put that transformer in the bell to run this little fluorescent lamp right here. But before I do that, I want to show you something really cool and interesting. And I'll be honest, I don't really know how it all really works. So here's the original speaker that was in the handset. If I pull this off, and you can see that there's actually two coils. Now, I believe that's a permanent magnet in there. Is that? Oh yeah, that's a permanent magnet. So, I don't know if that was for maybe making it louder so it could ring louder or what, but yeah. I assume this right here is the actual little voice coil though for making the diaphragm move, but yeah. Not really sure what the larger coil is about. No, don't know everything. Looks like it's not even connected. Huh. Interesting. Very interesting. The bell. Take a look at that. You know, here's a little solenoid. So when the phone rings, that metal bar will go back and forth, and it will strike the outside of the bell and make it ring. So ding is what you hear on the phone. We're not going to need the magnets. We're not going to need the coil. Well, we're not going to need a coil for this project, but I'm sure I'm going to use that coil for something. Let's go ahead and try and take this apart. Looks like I'm going to need some the radical tools for this. That's a radical tool. Oh, hey. Oh, no, wait, no, I do need to keep going. I need to save the mount or the bell. And I thought I could just take it off. I'll be getting magnetic dust all inside the speakers. Flip those over too. So many things to be mindful of when you're an engineer, right? Faster. Whew, that's hot. Okay, no. And now we can take the coil out. I'm gonna get underneath that. There we go. Ta-da! Let's see what kind of wire this is. Old wire. Decently thin. Looks like maybe 42 gauge. Don't need that. Okay. And now, I probably should knock those burrs off. I'll do that real quick. Put that back on. And then we're going to have to figure out how to mount this little transformer in there. I'll probably go ahead and hot glue it in there simply because I can. And this is going to be a hidden spot. And I'll have to run the high voltage wires out on the outside. But that should tuck in there nice and neat just like that. The bell will go over that and hide it. And the other thing I need to do is install the tweeter in the handset. Oh yes, the tweeter. So here's a little speaker right here, and what I'm doing is I'm putting in little speakers on both sides, just for some more treble. So I'm capacitively coupling them to the amplifier with about 20 microfarads of ceramic capacitors. That you can see that I have them right there. So very similar to what I'm doing with the transformers already. Let's see. You can see the one inside of here. So that's that. And it really does. I mean, it might not look the prettiest, but remember, functionality is what we're going for. Despite everything that I've done to this phone, it makes noise. I want it to sound clean. The microphone's hooked up to the Bluetooth phone. I mean, you could actually use this to talk to someone. It's still a phone. Okay, it's bordering on phone accessory, but you get what I mean. So yeah, let me go figure out how I'm going to install this transformer, do the final wiring and stuff like that, and figure out how the LEDs for the base are going to go in. This side is going to be pretty easy. This side, what I'll probably end up doing is I'll pull these wires out, and I might run them to some arbitrary location on the board, and then I'll use these two locations to run the LED out and over and in. But I have to check out where the spacing is before I do that. It's yeah, it should look pretty okay. I might even have room to run it under. So, options. But just like with everything in this project, I'm going to have to sit down and think about where things fit in all nice. So, yeah, that's where I am at. I wish I could film more of this, but honestly, it's a project that I'm just trying to get done by Christmas. Nobody's going to build another one of these. Or maybe they will. And I was the first. Alright, I think I have finally everything to finish off this project in front of me, so let's go ahead and do that. I went ahead and I installed the high voltage transformer inside of the ringer bell. I've got the wiring, so the audio signal from the amplifier will come in, pass through, go out to the speaker. And once again, the transformer is capacitively coupled with a 2 microfarad capacitor. Seems to be a good value. Here's the high voltage wires that will go to the fluorescent. And I also went ahead and installed the LEDs in the base of the phone, so they're connected to the board. I did exactly what I thought I would do, and I put this LED in where the red and the green wires were. And then luckily I found an open spot right here where there were 2 connections that I could just put those wires in, and it looks really good. On the back of the board, I went ahead and did the same thing I did on the handset, and I isolated the switch. I put a little SMD 100 ohm resistor in, and I put the LEDs in parallel. So that's all wired up. I think it's all good to go. So I'm gonna connect power to this, and then start with the audio wiring. Oh, I put a new song on here. Oh, let's start that.
SD card playback.
Yeah, we'll start from the beginning. We'll turn down the volume. Right, that can sit there. And let's go. So, power. So that's actually negative. LEDs don't work backwards. Now, we disconnect that. Yep. This wire has a spring to it. Go Gadget high hands. Alright, that'll be good. Now for the positive. Switch. If I knew I would have had to install a second battery in the headset, I would have never bothered hooking this up before. Of course, Hindsight, right? Hindsight. Right, that looks good. Go ahead and test it. Perfect. And let's pinkerify those wires. I think I may have gotten some iron filings in the speaker. I'll have to go ahead and check that out. Sounds a little fuzzier than it's supposed to. Right. No. Now, the capacitor bulb. I'm going to clean it out a little bit. Alright. Alright. Screw down the board. Yeah, I'm pretty sure I've just driven out all the audio files from my channel. It is what it is. Right. Now, gotta run speaker wire on this side. Oh, well, that would have been easier. Alright. See, this is what I mean by fiddling with wires. Not the fiddling with wires. Okay. Oh. Turns out I need to find the other short screw. I think I used the other short screw as an end cap for the other weight because the post was just broken off and I just ended up dumping a little bit of epoxy in there. There's just no way a repaired post could fix that. Oh, come on. There you go. Oh, that would say something. Oh, that was harder than expected. Alright. Let's see if the fluorescent works. That goes there. Make sure the outgoing audio signal doesn't end up shorting out. Like that. Cool. Okay. Now, I gotta join these together. Oh, let's see, which one's positive, which one's negative. You know, like phasing even matters on this thing, but... Okay. That one is negative. So that one is negative. Okay, so Here's the negative side. Put a little knot in there because it's going to spring back. Negative, that's the wire I want. You know what's funny? After working with wire so long, there really is just about a bazillion ways to strip wire. There's proper ways of whatnot, but man, there's like a bazillion different types of wire out there too. You'd be surprised. Wow. Okay, I probably should have put more than 2 sounds in there. Let's see if I can find some thinner heat shrink than that, maybe. I kind of ran through all my thin stuff. Alright, and then... there's the speaker. Alright. So at least power up the transformer in the ringer. Let's see if that little fluorescent flashes. Alright, here we go. We're gonna have to turn up the volume. Let's do that. Yes, it's a little flashing. Yeah. You know, it kind of works, but I think maybe if I throw a capacitor in there, I might get a little bit more performance. Yeah. Yeah. I'll probably end up throwing a capacitor in there, seeing if that helps with the output voltage off the transformer. But I'm not going to do that right now. I'm going to finish up the audio wiring. Okay, there you go. Finish up the audio wiring, and see how that sounds. Alright, so at last, my sister's Christmas present is done. I think it turned out fantastic. You would definitely have to take a closer look at it to realize that modifications have been done on it, and it's not a normal phone. But some things give it away. Of course, the SD card and the micro USB port. Obviously not from the 80s, but, you know, otherwise, yeah, it looks really good. It really does look good. Well, that's the inside. I have yet to figure out what I'm going to put on the little pieces of paper that go on the inside here, but I figured out before I put it in a gift box and give it to my sister. Anyway, let's go ahead and take this out for a test drive. There's some things that I've tried to do to get a little bit better performance. I did try to capacitively couple the output of the transformer to get this little fluorescent light to light up brighter. It didn't work, so I just kind of left it as it was. I mean, it blinks, but the volume needs to be a little cranked. Oh, let's see, what else? Oh, yes. Unfortunately, the original acrylic piece that I put in there to act as a speaker bracket decided it was just going to crumble into a million pieces. So I had to make a bigger one, a thicker one. It was a case of we need a bigger boat, so a bigger boat I built. Go ahead and turn it on. Put different music on there.
SD card playback.
Alright, perfect. Now I'm going to turn off the light. Turn the volume. Nice. Very nice. Turn off all the lights. And of course it has the LEDs on the inside of the phone, so I'll go ahead and turn those on. That is so cool. I love that. Oh. Yeah. Absolutely fantastic. Absolutely fantastic. Right, so I guess it's time to figure out what to write down on some pieces of paper and see exactly what my sister's response to it is.
Right. I saw that on.
This is like interesting.
Somebody shared that on Facebook. And
My God, it's a box. That's what I always wanted.
Yes, but it's a box made with love.
Well, no, what they do
I
is
didn't know
they
you
shoot
could
the
make
whole thing in
cardboard out of
Milwaukee
love.
red, paint it.
You make anything with love.
Or do a
I'll accept
Color
that
code.
answer.
Right.
and at that point just print the transfer and put it on.
It's paper with love.
It's it
Like
looks
a
like it's like
or
a.
whatever.
Yeah.
It's a submarine sandwich.
I was gonna say I feel like the people at Cousin Subs were like really high when they made this sandwich.
You know what water slide I'm talking about or not?
I can't see.
Okay, do you remember when we were kids we had model airplanes? You put the decals in the water and you split them off?
More tape.
Those are called water slides.
With love.
Yeah, I got the paper
This is
for that.
like
I printed
revenge
water
for
slides.
like those times as a kid where we'd like wrap everything in like
Okay.
20 boxes.
And then you
Absolutely
can
not.
black the top, done right.
It's structural paper.
Structural paper.
I mean,
Delicate
what
goods.
what
Oh, there's bubble wrap.
doing.
Okay.
Let's do that on my G26 here.
Layers.
Antissa.
Okay.
Instantly no.
26.
I know what this is. What?
You know what a 26 is?
I'm not heavily familiar with it.
Okay. You know what block 17 and block 18 are?
Yeah.
Okay. 26 is the baby.
Good shot, that.
Dude, this is
Just
epic.
wait, it gets better.
No, it's still 9
This is
dollars.
like
But it's shrunk
fantastic.
down.
Wait.
It's 12 rounds. But it tucks in the pocket.
We'll be back in a minute.
For sure.
There's power to it.
SD card playback.
Dude, this is trippy. You did all the things.
There's switches on it too. So the P and T switch on the bottom, flip that. And there's a ringer switch on the other side.
What?
So flip that right here on this side is a ringer switch.
There's a ringer switch. Is it down here? Where am I looking? Is it on the back? Oh. Dude, that's fucking trippy as shit, dude.
If you turn the music up, the neon's even light up.
Let's see. Okay, hold 4, 6. Oh, for like. Oh. I feel like it's gonna take me like a minute to like.
Yeah. Yep. Yep.
Dude, that's fucking trippy as shit.
You gave me the idea, and I actually found busted a Bluetooth speaker on the street one day, and I was like, now I'm committed. So I had to.
It is the Bluetooth.
Mm-hmm.
Oh my god, that's epic as shit. Dude, because we talked about it, because there's the old school like phone jack in the kitchen.
I wouldn't plug that into the phone.
No, but to like, you know, hang it up, because we're like, well, should we take it down when we were doing the remodel? And then like we were joking, like, no, we should get an old school phone and make it like a Bluetooth speaker, and then just like have that be like the Bluetooth in the kitchen. Dude, that's fucking like trippy as fuck.
You get a threaded barrel for